How's it going, physical science? Guys, I hope you're well. This is Mr. V from his shop. It's cold in my shop, so I'm wearing flannel. And we're here to give one of the physical science lessons for the last thermal energy unit that we're going to be having. All the things on thermal energy, which includes some math, which we're going over today. That's going to be on your test on May 8th, and there will be a 3-hour window open. And I need everybody to log on to that test during that 3-hour window, and I need you to take your test. All right, so we are still in school. I know a lot of you have senioritis hitting. Although you're not seniors, I'm the only senior in here. Check out the grade, people. All right, I'm the only one that can have senioritis. But we got to finish strong. Some of you doing great. I'm finishing strong. Some of you are, I don't know where you went, but you're drifting somewhere, and you will not get a science credit if you keep drifting. You got to pass. I'm not going to pass you. I'm not going to fail you. You're going to pass you, or you're going to fail you. All right, so let's make sure we get things squared out. One of the things that we have to do is make sure that we understand the change in thermal energy math that we have to do for this test. All right, now you guys can do this math. Every one of you can do this math, but I need you to keep a positive mind frame, because sometimes people hear the word math and their mind shuts down and think, I can't do it. Many of you proved to me that you can do it, and I should say all of you, everybody has proved to me that you can do it. So let's go ahead and figure out the change in thermal energy formula first, and then we're going to see how to work the formula. It's pretty easy. In other words, the change, oops, I should go here and put this down. This is going to be what I'm going to call T1, the first thermal lesson from me video. Now there's others that aren't going to have a T on it. They're going to be thermal energy things from YouTube, but this is going to be T1 lesson from me, heavy on the test. So make sure you get these things. The change in thermal energy formula starts out with Q. All right, and the formula is Q equals mass times Tf minus Ti times C. All right, let me go over these things really quickly. Q is going to be the whole change in thermal energy of something. It's going to be how much thermal energy change that we have in something. All right, now let's just say you have a really nice car, for example, and your car has a really powerful engine. Say you have a 350Z, which I'm jealous of if you happen to have one of those, and that engine is made of certain metals that the engineers need to find out exactly how fast those metals change, because the faster you get hot, the quicker you expand. So imagine what happens when the pistons on the inside of that are moving through the cylinder, but imagine the pistons expand much faster due to this than the surrounding cylinder. What's going to happen to your engine? You're going to heat up super fast, you're going to blow up, you're going to do damage to everything in the engine. So you have to make sure that you figure out all these different changes in thermal energy, and that's going to be Q. Q can be positive if it gains heat, or it can be negative. You can have a negative Q, you can have a positive Q. And we're going to measure Q in this unit that's abbreviated with a J that stands for joules. It's like a unit of heat, a joule. All right, now this one is really easy. This mass is going to be normally represented in a kilogram. That's supposed to be lowercase, so it doesn't look lowercase. Mass is supposed to be represented in a kilogram. You guys know kilograms. We have grams, we have milligrams, we have the bigger units, kilograms. So we're going to talk about kilograms when we do this. Now, the Tf minus Ti, this stands for temperature final minus temperature initial. Temperature final minus temperature initial. Okay? This is going to be represented in Celsius. Celsius is going to be the SI standard, so we're going with Celsius. Temperature final is the ending temperature minus the temperature initial. That's the starting temperature, the initial temperature. Okay? For example, it's morning in this class, in this shop, and it's cold. I had to put on flannel, it's so cold. All right? But throughout the day, it's going to get warmer and warmer and warmer in here. So let's say that it's, I don't know, 20 degrees Celsius right now, and later it's going to be 25 degrees Celsius. What is the temperature initial? The Ti? The Ti is whatever it started at 20 degrees Celsius. What's the final temperature? It's going to warm up to 25. So you would have 25 minus 20, and you would end up being a positive number, and eventually your Q is going to be positive because you're gaining heat. If you gain heat, you're going to be positive. You lose heat, the Q is going to be negative. All right, so this is going to be in degrees Celsius. Now I'm going to put this one over here, your C. This is something you don't need to worry a whole lot about it, but essentially you need to know what it means, but don't worry about all the numbers. But it's going to be a specific heat number. Specific heat. A specific heat is how easily something warms up or cools off. Now if you know certain things heat up really quickly and easily. An example of that would be aluminum. Aluminum quickly gains heat, quickly loses heat. But steel is different. Steel slowly gains heat and slowly loses heat. This is why if you go in your kitchen right now and you find pots and pans, take a wild guess what they're going to be made of. They're going to be made of something that has an easy ability, it easily loses heat or gains heat. All right, like aluminum. The bottom of most pans is aluminum. In my house, they're aluminum. If you have a lot of money, you might have copper pans. Copper is more expensive, but copper is also gains heat and loses heat quickly. I know sometimes when I make bread, I put bread on the aluminum foil, I put it in the oven, and then I open it, I don't know, 10, 15 minutes later when it's warmed up, and I can literally grab the aluminum that quickly because as soon as it hits that cooler air on the outside, it drops in temperature quickly. All right, so water is going to have a high value. It's going to take a lot of energy to heat up water. Aluminum is going to have a low C value. All right, now the crazy unit for this, and don't freak out about this, is going to be joules over kilograms Kelvin. So when you report this, you report it in this unit, joules over kilogram Kelvin. Don't worry about all that. It's just like the density unit was the mass over the volume, so it was like grams over milliliters, but this is going to be joules over kilogram Kelvin as the unit. Okay, so this is what we're looking at in terms of the formula for this chapter that we're looking at, this unit that we're looking at. I'm not going to give you this on the test. You have to remember this on the test. All right, Q equals mass times TF minus TI times C. It's going to be easy because I'm giving you, there's 4 different things here. 1, 2, 3, 4. You might argue there's 5 if you say these are 2 individual numbers. I'm giving you all of them but one, okay? And you have to solve for the one I don't give you. In other words, if I give you something's mass, I might tell you the final temperature, I might tell you the starting temperature, and I'll give you this number. And so all you have to do is use common sense, figure it out, and you're going to figure out the Q value, which can be what? Can a Q value be negative? Yes, yeah, thank you. Yes, I heard you say that. Yes, a Q value can be negative. Can it be positive? Yes, of course it can be positive. What does it mean if a Q value is negative? It means it got colder. It got colder. It's like I take some of you who didn't even log in for your test, and so you have to take late credit. It's like I take you and I chuck you in an iceberg-filled ocean for 10 minutes as punishment. What's going to happen? Your body temperature is going to get colder. Okay? So you're going to have a negative. You'll have a negative Q value. All right, so this is the first one on this. I'm going to show you some example problems on the next video we have on changing thermal energy. But quiz after this. Get your notes, understand it, go take the quiz. You guys have a wonderful day. This is Mr. V signing out from his woodshop.